Okay, question 1. Alright. What percentage of 40 is 8? We simply put what? 8 over 40 times 100%. And then we're going to divide by 10, give us 4. Divide by 10, give us what? 10. And we can say 4 into 4 goes once, into 8 goes twice. 2 times 10 is 20%. Alright, good stuff. Next one is going to be, we have 2/3 raised to a negative power. Now, when you raise a quantity to a negative power, you want to write it as a positive index, you can flip it. So, if I gave you A, it's the same thing as saying A over 1, right? And I raise it to a negative power. Let's say negative 2. Then I can rewrite this as what? Flipping this, A over 1 as what? 1 over A? And then put it back to power, but the power will be what? Squared this time. These two are the same thing. So I would end up with what? 1 over A times 1 over A. And of course, 1 times 1 is? A times A is? Right. So the same concept we're going to use for this one. Okay, so how would you do this one? Tell me what to do for this one. Oh, sorry. Let me shrink it a bit. Give me a second. I think that's good. 1 second. Yeah. Everybody can see? Okay. So, using the same concept we used a while ago, we have 2/3 to the negative 2 power. We can do what? What we're going to do? Flip. So we have 3 over 2 squared. And what do we do here? We square in a number. So we're going to say what? 3 over 2 times what? Right. Powers mean multiply the quantity by itself. So A squared means what? A times A. So 3 halves squared means what? 3 halves times 3 halves. Now what is 3 times 3? 9. And 4 fours, 2 twos. And the answer would be what? Right. Next one, number 3. Everybody's clear with that? You want time to write it down, or is good? Okay, I'm recording it so I can just send you the recording then. You did the other one get 4 over 9? Okay, so that will be not correct. So you correct it, right? Okay. You must, once it's a negative power, flipping it is best to guess. Because it's not, you're not asking for, you didn't ask for, what was the original one? 2 over 3? He didn't ask for this. He didn't ask for this, guys. That's not what he asked for. What you were given? Negative. Right. Once negative, now you have to flip the fraction. Got it? This is not equal to this. It's not equal to 2/3, the square of 2/3. These two things are not the same. One has a negative power, so it cannot be the same as one with a positive power, unless you flip the fraction. Yeah. Clear? All right. Okay, the next one. This one, do you know if you do square numbers? All right, here's my idea. Memorize them. It's not hard. All right, let's. No. 11, your double digits. Square of the double digits in the teens. Like we can start from. Let's start from 11 then. You know that's not in the teens. 11 squared is what? 121. All right. Just add the two digits 1 and 1 and put the 2 in the middle. 11. 1 plus 1 is 2. Put it in the middle. When you multiply by 11, that's what you usually do, you know. Watch like this. 11 times 32 is what? Put the 3 in the 2, the 32, and leave a space, and add 3 plus 2. 3 plus 2 is what? So that's 11 times 32. That's a rule. That's a little trick when you're multiplying by 11. Just separate the digits, add them, and put the answer in the middle. Alright? So if I say 11 times 45, what's the answer? Quickly. 4 and 5. What's 4 plus 5 is what? Right. If we say 11 times 47, then you're in a little trouble there, because guess what? When you add 4 plus 7, you're going to get what? What are you going to get? 4 plus 7 is what? You put the 1 in the middle still, but you change the 4 to 1 up. So you make it easy because it will always be 1 up. As long as you get over 9, just up the first digit. So you know it's going to be 5 instead of 4. So if I say 11 times, let's show you quickly. If I say 11 times let's say 78. Right away, you know that 7 is going to change to 8, isn't it? Why? Because 7 plus 8 is going to pass 9, isn't it? So right away, there's going to be an 8 here. You're going to have an 8 at the end. And 7 plus 8 is what? 15, isn't it? So 5 there. 8, 58. 11, just 11. It'd be nice if it worked for everything, isn't it? End of all this drama. But there are tricks for all of the times tables, so you can always check them out. But we're not on that though. So let's just get back to this. That's why I just say if you multiply by 11, it's 11 times 11, isn't it? So because we're multiplying 11 by 11, I can choose what, look at it. I can just put the 11, the ones apart, and 1 plus 1 is 2. That's it. Got it? Okay, let's go to the 12 times. We know that by heart. 12 12s is what? 144. A nice trick is to do what? Square this number here. Square 2, get what? 4. Double 2, what you get? 4. And put back the 1. That works, isn't it? Let's try with the 13 times table now. 13 squared, I mean. We could also do it with 11, you know. Square 1, you get what? Square the 1, you get what? Double 1, you get what? 2. And put back the 1 at the end. Clear? This is for squaring numbers in the teens. So when it's square 2, you get 4. Double 2, you get 4. Put back the 1. Try the 13 square and tell me what you're going to get. Square 3, you get what? Not 6. 3 3s, 9. Double 3 now, double it, you get what? And put back the 1. For the 14, you don't need to memorize that one. When you pass 13 and 14, they can have something similar. Just switch the 6 and the 9 around. What are you going to get? 196. Just remember that one. Flip it around. Although you can square the 4 and get what? 16. So put down the 6. Double 4, what do you get? Plus the 1, 9, and put down the 1. The 15 squared, do that one quickly. Square 5, you get what? 25. Okay. Double 5, you get what? Plus 2, 12. Put down the 2. And carry the 1 on the 1 at the end, you get what? 225. 16 squared. Huh? 16 squared, what about that one? 6 squared is, so square double put back, right? But sometimes you have to carry if it goes over. 6 squared is what? Put on the 6. Double 6, you get what? Plus 3, 15. Put on the 5. Carry this 1 to the 1, you get what? 256. Let's try the 17 squared. Square 7. Put on the 9. Double 7. 14 plus 4. 18, right? Let's put on the 8. Carry the 1 to the 1. 289. Clear? Alright, so it's helpful, right? Fast, right? Okay, here's the thing now. Let me answer this question. It says 17 squared. So we know we have 17 squared already, isn't it? What's 17 squared? I mean, you're not going to go in the exam and do all of these. That's what they require. 17 squared plus what? 15 squared. Alright? So let's work on that. So we know that square root of 17 squared minus 15 squared. 17 squared is what? 289. I know to get that quickly, right? And 15 squared is what? 25. You follow the fast method, right? Square, double. Sometimes you have to carry it, so that's okay. Alright, what is 289 minus 225? That one is easy. 64. Alright? And 64 is a square number because a number times itself gives you 64. What number is that? 8. Alright? The other method to use is called, one second. Anyway. Okay, so for this one, do you remember this concept, difference of two squares? That if we have a squared minus b squared, we can write it as what? The product of a binomial's conjugate, plus in one bracket and minus in the other. So let's take the square root of the what? The a squared. So a here and a here, and the square root of this one as well, right? Let me not confuse the concepts with how it's written. So we can take the square root of a squared, which is a, and the square root of b squared, which is b. All right, and that's is saying the same thing as this above. We know that because a times a is what? What's a times a? A squared. What's b times negative b? Negative b squared, right? But when we look at this inner, be 8ab, and look at this outer, negative ab, you end up, what happening here is that the a times b gives you what? Positive ab, put the a first, alphabetical order, and the a times negative b is negative ab. What happened to these guys here? Same term, but different signs. So you're gonna, this is really 1ab minus 1ab, cancel out. So all we're left with is just what? The a times a, which is a squared, and the negative b times negative b, which is negative b squared. So you end up with a squared minus b squared. So the in and outer cancel. That's why I'm saying that a squared minus b squared is simply a plus b multiplied by the quantity a minus b. Now with that fact, it enables us to work out this easily. Let me show you. Let's go down to this point here. 1 second. If I have the square root of what? 17 squared minus 15 squared, I can simply do this. 17 squared minus 15 squared is the difference of two square numbers, isn't it? Look at this, guys. Very simple. Is this the difference of two squares? In this case, a is what in this case? And b is what? So I can still put the plus and minus and put what? 17 here and put what here? 15. And what's 17 plus 15? That's 32, right? 32? Yeah. Multiplied by, what's the result of this? 17 minus 15. 2, right. So go back to the top. That this whole thing works out to 32 times 2. What's 32 times 2? So it's square root of 64, which is what? 8. Quick entered? Yeah. You want to take it down? Alright. We're saying that, okay, what square root of what? Square root of 169 is what? 13. The square root of 196 is what? 14. And between 169 and 196 is 191. So square root of 191 must lie between these two numbers. So it would be between what? 13 and 14. So the answer to this question, number 4, is C. C? Yes. Yeah, C. Number 5. All I did with this one is this, 99 times, and I separate the 101 into 100 plus 1. You agree with that, right? That is still saying 99 times 101? You all agree with that? But this allows us to use distributive law. Remember, distributive law is this. A times B plus or minus C means what? A times B times A times C, isn't it? So A times B is A times B, right? Plus or minus what? A times C. Everybody agree with that? If I have a plus, then I will put plus. If I have a minus, I'll put minus. So, everybody agree with that, right? What kind of law we call that? Big with D? Distributive law. So what we have here is 99 times 100. So we're going to do the same thing. 99 times 100 is what, guys? 99 times 100. Let's put it there. Don't put the answer itself. Just write it like 99 times 100. And then we're going to say what here? 99 times what? 1. Put out the plus sign and put this in bracket. 99 times 1. Alright, which answer that looks like? Option? Which option that looks like? D. Clear? So all I did was use distributive property, but they basically split the 101 into 100 as a base, because it's easy to work with 100, isn't it? For instance, guys, if we were to work this out, the reason why they're doing that, they're showing that there's an easy way to multiply 99 by 101. They said 99 times 100, and then said 99 times what? 1. Because what's 99 times 100? Yeah, 9,900. And what's 99 times 1? It's so easy this is to work out by using that method. What would the answer is going to be? 9,900 and? Yeah. So we tend to use this method a lot, you know. We use this method too. For instance, if somebody were to ask you to multiply this, I'm sure some of you have used this method. Like 13 times 2. You guys have used this method. You say, okay, I can say 13 times 10, and then 2 times 10, and then 2 times 3. You guys will do that in your heads? Like splitting up the 13 into what? 10 plus 3? Have you guys ever done that?
Yeah.
And say what? 2 times the 10, and then 2 times the 3? Because 13 is really 10 plus 3, isn't it? So in your head you might say, okay, well that's going to be what? 2 times 10 is what? What's 2 times 10? 20. Plus, that is plus sign, 2 times 3, isn't it? What's 2 times 3? That's 26. Let me see the answer of those who have ever split up numbers like that when you're multiplying. You split up like that, right? What is really distributive law you're applying? This number here is number 5. I don't think we spend an hour doing this. I think we spend a lot of time doing other.
I understand.
Yeah. I'm gonna have to edit that out though. Let's clear that. Okay. If you look at the time, it's only 16 minutes past. Alright, 40 students in the class. Girls make up 60% of the class. 25% of the girls wear glasses. How many girls in the class wear glasses? How are we gonna do this one? Huh? You find 60% of the 40. And so you can say what? 60% of 40. 60% of 40. What's the answer for that? That will give us the girls who make up the class, right? So we're going to say 10 to that goes 10 times. 10 to that goes what? 4 times? Then 10 to 10 goes once. 10 to that goes what? 6 times? 6 fours? So that's telling you the number of girls, right? 24 girls. But how many of those girls wear glasses? 25%. So 25% of the 24. Now 25% is really what? What's 25% is? We looked at that before. A quarter. So that's a quarter of 24. What's a quarter of 24? 44 goes once into 24 6 times. Clear? Alright. One other thing, if n is, yeah, then the number of subsets as what? This means if the number of elements in A is equal to m. Alright, the number of elements in A is equal to m. So if, for instance, if I have this set here with A, B, and the number of subset I can get from this, I could get A as a subset, I could get B as a subset, I also could get the subset, the A, B itself as a subset. It's a subset of itself. We call it an improper subset. And then we also have the null set, which is a proper subset of every set except itself. If I give it an empty set, then it only has one set, which is itself, and then that will be an improper subset. But of every other set, the empty set is a proper subset. So this is a proper subset of set with A and B. B is also a proper subset. This one is an improper subset, and the empty set would also a proper subset of this subset. So how many we have? How many subsets we have? 4. And if we use a formula in A, that we're given as option A, 2 to the m, with 2 to the power of, the m stand for the number of elements in this set, for instance. Let's call this A. How many elements we have in A? 2. So it's 2 to the 2 power, which means 2 times 2, which is 4. That's why we have 4 subsets. Understand that? So if I were to increase this, guys, if I were to increase this, the number of subset by 1, let's call that C. How many subset would we have? How many subset? Using the same formula. To the power of what? M in this case will be what? 3, ain't it? Okay, 3 elements. So it will be 2 times 2 times 2 give us 8. So if you look at it, the improper subset will be A, B, and C, right? Elements. Improper subset of itself, right? Subset of itself, improper subset, we call that. But we can also get double sets, A with B. What else? A with what? A with C. Let's do double sets so far. Double elements. B and C. Any other combination? Single sets, right? A. What else? B. Any other one? C. Any other one? And the empty one? How many of them we have so far? Miss any? 1, 2, 3, 4, 5, 6, 7, 8. Right? Everybody get that now? Alright, so which are the option? A, B, or C? Or D? A. 2 to the m power, where m stands for the number of elements in the set. Got it? I'm going to upload the video so you can watch it again. You have to pay attention because of time. It's going to be hard for me to go over. So I'll either explain to you separately or we just watch the video. I'll send the link. Okay. Let's go on to the next one. Let's look at this one quickly. So I have to stay focused because I was actually explaining it and give 2 examples. Which of the following statements describes the set of integers greater than -3 but less than -6, right? Set of integers here is represented by what? Set of integers is represented by what? Guys, you can watch YouTube videos, right? And they just work out the questions, but if you don't really get the concept, another question comes and you can't do it. So you really need to know the ins and out of it. So I want to just give you that breakdown. So when you see a question like this, you're going to really handle it. It's really hard to understand that, but that's important. Oh, the set of integers, we usually use the letter Z, right? And when we talk about integers, we're talking about what? We talk about whole numbers starting with 0, right? We have 0, 2, 3, and so on, going in that direction. So we mean like 4, 5, 6, etc. And less than 0, we'd have what? -1, -2, and so on, going, right? You understand that? No fractional parts. That's what we call integers. No fractional part. So you have to understand that. Integers are just what? Positive whole numbers, negative whole numbers, including 0. So when we talk about set of integers, we can choose numbers from this set. But if we choose the numbers from this set, the numbers must be what? Only whole numbers, positive, negative, or 0, including 0. Alright? But we can't choose numbers that are going to be in between them. No 2.5, no 2.1, no. So those are what we call integers. Now, let's go on with it. These integers represented by x. So if I choose some numbers within this, I can call a set of values represented as x. Now we tell a set of integers, let's call it x, is what? Greater than -3. So I have to go this direction. Greater than -3. Why is that? When I read this direction, I'm saying what? X is what? Which part do I meet first? The opening. Once you reach the opening first, going this from left to right, or right to left, sorry. Going from right to left, which should I meet first? The opening, isn't it? So the opening will say what? This opening here says what? Greater. Greater than. If I meet the small part, what would I say? First. Less than. But that's only if I'm going what direction? From left to right. So read it from left to right. What am I saying here? -3 is what? Less than x. Yeah, -3 is less than x. But if we're going to, from right to left, I'm saying what? X is what? Greater than -3. Get that? Okay, let's go the same direction. We want to say x is less than 6. So after x, we're going to go this direction. X is less than 6. How we write that? The small part or the big part first? Right, because we want to say x is less than. So we'll meet this part first by going to the right. X is less than 6. Should I put the dash underneath the symbol? What would the dash under the symbol mean? Equal to. Right, the dash will mean equal to. And the statement did not say anything about equal to. So that we know B and C will be out, isn't it? So which answer is the correct answer? D. And they told us that x is a member of what? Integers, isn't it? That means no number in between, no fractional part. X is a member of integers. This set up there. Is that clear? Alright, good stuff. Alright, now let's drop down. I know time is going, boy, but to explain these things take a while. Because we want to make sure we understand, just in case CXC decide to give you something you never see before. And saying, boy, I never see this and no other multiple choice. I did 10 multiple choice set and not one thing showed up. Mr. Lennon prepared me, and, he didn't prepare me well. Now, for this part, you need to understand the different type of sets we have. We have this joint set. What that means? They have no members in common. So look at the first one, the F set and E set. The F set is the odd numbers, right? Set of odd numbers. And the F and the E set is what? Even numbers, isn't it? So in this set, basically what you have, a universal set, E or U, let's use U. This means we have common members, isn't it? We call it, this is a joint set, or intersecting set. But that's not the case for what we're given. We're given odd and even number. Is there an even number that's also odd number? No. So therefore the set is going to be what? Disjoint. Yeah. So if you have E for even and what? F for odd, then we'll have no common member. In other words, you won't have the intersection of the two circles. Right? They won't intersect. They'll be separated. That means they're what? Disjointed, isn't it? In other words, A, alright, set A, no, set E, by the way. Set E. Set E intersect with set F will give me a result. What the result will be? Not 0, because 0 is a number. The empty set. So I put this like this. I put a set with nothing inside. Remember I said empty set is a part of every set? Yeah. So this is one way we can say that it makes sense. E intersect F is the empty set, meaning that nothing will be inside that set because there's no intersection actually, ain't it? So the number of elements will be 0, yes, but in terms of the E intersect F is the empty set. What's another way of representing the empty set? We can also say what? The null set. Alright, it's null. So we can use either of these two symbols. A circle with a slash through it, the null set. Seen it? This means the what? Empty set. And this means what, guys? Over here. Null set. What about if I put the number of elements in this? Number of elements in E intersect F. I got the answer early on. The number of elements. This is notation for it. Number of elements in E intersect F. What's the number of elements? You're just going to count. How many elements in this is in its intersection? No. There's no element in the intersection.
Yes.
So what would the answer be? No. The number of elements. This is a 0, yeah. This notation means the number of elements. This is asking you to list the elements. Intersect F. So you're listing when you're listing the elements, you put the braces, the curly brackets. When you listen to the elements, you put the curly braces or the brackets, curly brackets. But because we put the curly brackets, we can't put any members in it. We say that's an empty set. We leave it empty. But once you're counting, you use this notation, N open bracket, and put the set inside. Intersect F. Alright? This is notation for what, guys? Number of elements in whatever set. Right? Guys get that? The number of elements in whatever set. The multiple choice questions allow you to do what? Explore topics, a lot of topics. So me going through this is really not me trying to cover multiple choice, but I'm actually covering a lot of topics in one. That's why it takes a little while to explain them. Now, let's go to the next one. Let's see if anything that we learned earlier. Let's see if anything. Yeah, A, what was the answer? Oh, I didn't explain. Oh, what would the answer there, guys? I'm still in such a hurry. Answer will be what? A, yes. Why A though? Why A? Yeah. There's no common member. No common members, right? And I want to explain as well, when do you have a case where you have something like this? Like you have set B is a subset of set A. It means that all the members of B can be found in A, right? So for example, set B has numbers 1 and 2. And set A has numbers 1, 2, 3, and 4. What do you realize about those sets? That B is a what? A subset of A, ain't it? That, in other words, if I list the members of B, what would you list? 1 and? If you list the members of set A, what would you list? 1, 2. Right. But when you realize that all the members of B can be found in what? All the members of B can be found in A, isn't it? That means B is a subset of A. Right? Right. So when you're drawing the set, constructing the set, you do something like that, right? Universal set, and you have B in A. By the way, both B and A are what? Subset of the universal set as well. I'm going to use this notation. B, let's write it properly. B is a subset, a flattened C of A. And A is a subset of what? The universal set. Which implies that both are subset of the universal set. So this notation means what, guys? What that notation means? This symbol here. Subset of, yeah. Yeah, subset of. Now, basically, I've explored a few things about sets. Can we use that information now and answer? Look at the other options. Look at B. Look at solution B. What would that one be? Subset or intersecting set? Intersecting, right? Because they are members of A that are not members of B. And they are members of B that are not a part of A, isn't it? So they're not subset of each other, or one being a subset of the other, but they would be joint set. They have members in common, or intersecting set. Okay, guys? But by the way, I can also explain something here, just in case CXC give you that question. I can go back to the subset for a minute. Look at this, guys. If I say, just like the last one, A intersect B will be equal to what? What A intersect B will be equal to what? What members? You're going to have an intersection, even with subset, the subset. No, the example I use in here. You have the universal set.
Oh, it will still be 1 and 2.
Be 1 and 2, ain't it, guys?
Yeah.
A intersect B will be what? The subset, the members of the subset B, ain't it? Because that's the members that they have in common. The intersection symbol means what? This means what? Right, it means members that they have in common. Alright? Yeah. Hmm? This joint, I use it. No, I wouldn't call this one joint. I don't call it this is subset. Subset. As a subset, meaning that all the members of B can be found in A. I call that subset. Alright, understand? Just stick with subset because all members of B can be found in A. Clear? Alright. Now for the intersection, want to differentiate it. Like in this case. This is an example of P and Q. Because they have members in common, but they also have members that are not in common, isn't it? Right. What are those members? Give me some members. Give me some of them.
Common.
6 are multiples of 6, 12, etc. Right? Members that they don't have in common. 4. It's a multiple of 2. What else? 8. What about 3? 9. And so forth, right? Yeah. So that's one is the intersection. But the subset, I just call it subset. So to differentiate them. What about set C? That's what? A subset or intersection? Option C. Yeah, multiples of 5 and factors of 20. Intersection, right? But they have members that are not in common, right? Alright, what about D? Whole numbers and rational numbers. The question is, what are rational numbers?
The rational numbers are numbers from 1.
No, rational numbers are any numbers that can be written as a ratio. Rational ratio. And the ratio must be what? The ratio must be A over B, where A and B are members of set of integers. So it must be written as a fraction first off. So when you have ratio, we think about what? Fraction, right? And when we have fraction, we think, for this case, the numerator and denominator must be what? Members of what? A set of what? Integers. So the set of numbers where A and B come from must be what? Like negative numbers and also positive numbers, right? Positive whole numbers. So A and B, well, I would say where B is not 0. Alright? I would probably include where B is not equal to 0. Right? 1 second. I wrote this wrong. Where B is not equal to 0. Okay, you can divide by 0. Alright? You get infinity. Should do that. Like, if it's a positive number on top, you get positive infinity, negative number on top, you get negative infinity. But B should not be equal to 0. But basically, in other words, give me a rational number. 3/4. The numerator must be an integer, and the denominator must be an integer. Perhaps, let's see, 4 3s is what, 12? I want 13, so 13 over 4, right? So yes, that's a rational number. Because the numerator is an integer, and the denominator is also an integer. Positive whole number or negative whole number. Alright, so give me another integer. All whole numbers are rational numbers. All integers are rational numbers. Because all these integers can be written as what? Can be written as a fraction. Like 0 itself can be written as what? 0 over what? 1. 0 is an integer, and 1 is an integer. So this is a rational number too. Negative 2 can be written as a rational number. Put it as over 1. Right? You have integer over integer. What are rational numbers? Numbers can be expressed as what? As A over B, as a fraction. Where A and B are what? Integers. Integers. So rational numbers, and why we call it Q though? It's usually represented by the letter Q for rational numbers. Because Q stands for what? Well, you can think of Q standing for what? Quotient. What is quotient? Quotient is the result from what? What is quotient? When do we get quotient? It's the result from what? Okay, what's product? The result from what? Multiplication, that's product. Quotient. Yes. Quotient. Alright? It's the result from division. And when we think about A over B, we see division, isn't it? So I would say that's where they get the Q from. Representing the set of rational numbers. Because you have a division, right? So the set of rational numbers, alright, can be represented as A over B. Where B is not 0 though. A can be 0 but not B. Integer over integer. So therefore, what can we say, guys? All whole numbers are what? Rational numbers, isn't it? So set of whole numbers is a what? A subset of what? Set of what? Rational numbers. Everybody get that? Set of whole numbers is subset of the set of rational numbers. Because all whole numbers can be expressed as what? A over B. Give me a whole number that cannot be expressed as A over B. There's none. All of them can be expressed as some number, integer over some integer. Alright, we can put all of them over 1. And the same value. Okay, so what can we say? D is what? A subset, isn't it? So in other words, we'll have what? Universal set. The set of what? Rational numbers, Q. And within that we have what? The set of what? Whole numbers. Alright? Because we have other numbers that are not whole numbers that are rational numbers, isn't it? Like for instance, 2 over 7. Is 2 over 7 a whole number? No. But is it a rational number? Because we have a what? Integer divided by an integer. So that would be a member of Q but not of W. Alright? What about, let's look at this one. I think I taught you enough that you can answer this one. Given that A is equal to 1, 3, 6, 8, 9, 12, 15, and B is equal to 6, 9, 12, which of the following statement is true? You learn enough to answer that question. Right. See? So quickly right away, we learn enough that we can start answering the questions. So we can move on from that, right? Oh, we didn't touch that one. That's the old one we did not touch, right? The complement. What complement means? For instance, if I refer to two people going home, right? Right? Anybody going home? Like taking anybody home? Anybody taking anybody home? No? Okay. Right. So you're taking her home, right? So the complement of persons going home with you would be who? Everybody, all of us, except the person taking home. That's complement. You never said that the husband is a complement of the wife, or wife is a complement of the husband. You ever heard that? What would they mean by that? The wife complements the husband. Children, right? Like the children, deal with the children. The husband might be a little rough with the children. So here come wife now spoiling them. Yeah, that's what it's, yeah, true. You think of it like balance as well too. Like what the husband lacks, the wife has, right? So that's complement in a sense. We can apply it to the same thing here. Like if we have a set, universal set, and let's talk about A again. And you have 1, 2, 3, 4, 5, universal set. What are the members of set A? 1 and 2. What about A complement? What would that be? 3, 4, 5. Everybody understand that? 3, 4, and 5 are not members of set A. So we call it A complement. In other words, when you combine A with A complement and use the union symbol, when you want to combine two sets, the union symbol means you're combining everybody. When you combine A with A complement, in other words, A union A complement, what set are you going to get? The universal set. Yeah. A set and its complement will give you the universal set. Any set and its complement will give you what? Yeah. For instance, people in the world, you and your complement will be you and, like for instance, Nerissa and Nerissa complement will be everybody in the world, isn't it? Everybody get that? Because everybody except Nerissa will be everybody else in the world. With Nerissa, we'll make about everybody in the entire world. Make sense? Yeah. Clear? Following? But if you follow? Okay. Alright, so I think we finished with that one now. Can we move on now? I think this one is a little bit. Let's look at this one. So the students in the class. Anybody want to read that one? They'll have to read. Alright, so how you went through that one? I usually start, I will look at it from this viewpoint. The number of students who own cats is 12, right? The number of students who own what? Dogs is what? 16? And I start to eliminate. Look at the first one. Why would you eliminate the first one? You have to look within the circle. How many persons own cats based on the circle for A? Not 12. 12 plus 2. 14. So you eliminate that one, isn't it? Because that is saying that they have 40 people who own cats, isn't it? Sapo? Sapo not paying attention at all, Sapo doing all the questions. Alright, so the number of persons who own cats is 40. Everybody agree that? Based on A, isn't it? But was that what's given to us? So A is out. B seems to be correct, isn't it? Based on that, just this information only. Isn't that true? Look at B. No, I'm saying based on just this information. It seems to be correct based on just this information. Why? Number of person who owns cats is 12. Is that true for B? Number of person who owns dogs is 16 based on for B? Right. And how many persons they have altogether? When you add 16 plus 12, you get 28. Plus 2 outside, you get what? The 30 students in the class. But the problem with B is what? This next information. Where it says that all students who have a cat also have a dog. And this is suggesting that's not true. Because if that's the case, you'll have an intersection. Do we have an intersection here? No. This is suggesting that what? The persons who own cats don't own any dog, isn't it? So we have to skip out B. Let's turn to C. Why is C not correct? Yeah, the number of cats, number of person with cats is what? 14, isn't it? That's not true. We didn't even look at the number we own dogs there. That's 18. So that even make it false again. Let's look at D. The number of person who own cats is 12. True? Number of person who own dogs is what? 12 plus 4, isn't it? That's what? 16? That's correct. And 16 plus 14 is 30, correct? But that's also telling us that the persons who are within the circle for C is 12, isn't it? But you're also part of those who own dog as well, isn't it? Yeah. Because the 12 is within the circle. The number 12 is within the circle of D, isn't it? That's suggesting that the number of persons who own cats, which is 12, those 12 persons also own what? Dogs. And that satisfies the information that we were given. So I'm reasoning with you, and that took up some 3 minutes or so. But when you're doing it on your own, that same amount of explanation I gave to you, the thinking is like lightning. My explanation is like thunder. Lightning is just light is very fast, isn't it? You could think about everything I told you there in about what? 20 seconds. Y'all realize that, right? So again, my explanation is gonna be long because it's an explanation. But if you look at A, you quickly will do what? Look within the circle of C and C is 14, and that's out. You move on. Okay, that seems to be correct, but guess what? No person who owns cats is 12. Is saying that they don't own dogs, that's out. Number person within the circle of C is 14, but it's with 12, that's out. That's less than 20 seconds still, right? So D must be the answer. I won't even have to look at D. I just put down D. So fast at this, guys? Alright, so the explanation is long, but you will just be able to not that off quickly. Can I just give you all this one? A intersect B complement means what? All those are part of A, but not B. B complement means not a part of B, right? But A intersect B complement means what? A part of A, but not B. You can accept it, if you want me to explain it to you, it's up to you. Do you want an explanation or you want us to accept it? Okay, do you know it already or should I explain it? Do you know this already? Huh? If you don't, just tell me. Do you know it already? Let me see those who know this already in terms of why is the case. Do you know it? What about you? Oh, no. This is intersect B complement. A different version? Okay. I think I'm gonna do it though. I don't think you really fully understand it. I think you just try and get away from it. This is A and this is B, right? Let's put in some numbers. 1, 2, 3, 4, 5, 6. Give me A complement quick. Give me A quickly. 1, 2, and 3. Very good. Give me B complement. B complement. B complement. 1, 2, 5, and 6. See what I say? Let's do it. What B complement means? They must not be within the circle of B. So when I say intersection now, you must remember what the word intersection means. What's common, right? So what's common in the set? What's common in the set? A intersect B complement. Let's see. What's common in both of those sets? 1 is common, right? What else is common? 2. So that's 1 and 2, isn't it? And if you look at what I selected in terms of 1 and 2, look at what I selected in terms of 1 and 2. Look at the set again. Do you realize it's just this portion of A that we selected? I'm shading what? I'm shading the part of A, but which part am I avoiding? The intersection, isn't it? So I shade everything except the what? I shade everything except the intersection. So what it means is A except the intersection. And we call that A what? A only. So A is 1, 2, 3, isn't it? A will have members 1, 2, 3. But A only has what? The 1 and the what? The 1 and the 2. Everybody get that? Says A only. I see why, isn't it? Because A has what? 1, 2, and 3. B complement has what? 1, 2, 5 and 6. What members did I cover? 1 and 2. Those are what's common as intersection. Clear now? Okay. So when we look at this, guys, if I ask you guys, look at this one. Let me see if you all really understand. Let me test you guys if you all really understand. Because you always say yes, no, I understand. So let's do this. I know, because some persons don't want to keep back some persons, you know, I understand. But don't think like that. What is B intersect B complement? What's B intersect B complement? Give me the answer right off the bat. What's B intersect? Huh? 4. Just 4, isn't it? What this means? B only, isn't it? Those members of B that are what? Not a part of, and that will be 4, isn't it? 3 is a part of B, but why are we not including it? Because it's a part of what? A. So we say B only. We don't want any part of A in it. Right, excellent. So looking at the answer here. Look at the answer here. A intersect B complement. Which one is shaded? Look at option A. What is shaded for option A? And how do we symbolize that? In set notation, in set form. Where everything is shaded. It must be what? A union B. Mean everything, yeah. A union B. That's option A. What's option B? What is option B? What's the notation for that one? A shaded, isn't it? But is it all part of A? Is it all part of A shaded for B? No, we left out what? The intersection. And so we left out the part that belongs to B, isn't it? So we're going to say what? It's what? A intersect B complement. We're leaving out that. So that's the answer, right? How would you, I need you to understand each option. In other words, CXC could give you those same options, but change notation. There's actually a CXC question with option C. There's actually a CXC set question with option C. Alright, what's option C, guys? Tell me. Oh, the wrong side. I'm actually screwing up. Yeah, what's option C? No, look at option C again. No? No. Well, true, but what asset notation? What is that? You guys thinking too hard, man. The set notation for C. Or the shaded region. Shaded region, give me the set notation. B complement? No, because part of B is still shaded. B complement means not a part of B. And part of B shaded. I want to see who gave me. Okay, the person who give me the answer within 5 seconds, I give you $1 million. $1 million. Yeah. By the end of class, I'll give you the $1 million. You have 5 seconds. 1, 2, 3, 4, 5. Anyway, y'all get money there. I can explain like this. Watch this. No, can it be A only, guys? No. Because B is in it. No, A only is leaving out B. So what should it be? Give me the members of A. In this case. 1, 2, and 3. Is that correct?
I know. B intersect A. B intersect A.
The answer is right on the board. I give you an example. List the members of A, guys, for me. What are the members of A? 1, 2, and 3. So if I ask you to shade A, what would you shade? Where 1, 2, and 3 isn't it? Okay, look over there. Is that the same thing you're seeing? What's the set notation? Just A. No, not A only, no. A. The 3 is part of B, so you can't say A only. But it's A that's shaded. Its answer is just A.
You have $1 million?
Yeah? You never know.
Yeah, but I'm money.
No, but you didn't get it.
If I get it for money, I don't know.
Wait, you get it. You don't got it, man.
No, man, I wouldn't.
No, you don't got it. You don't got it.
I wouldn't do that to you.
No, I'll give it to you, man. Don't worry. The question is whether or not you'll be able to take it off the board. I would just, no man, I would just say, wait, what, US? Look, US 1 million.
Hey, you want to see what's happening?
Huh?
I didn't get it, so sorry.
No, you'll take it. If you can take it off there, that would be good. Somebody good with that though, right? So basically, we almost have a cover sets now for this, you know.
And sets always come.
Yeah, sets always come. Yeah, set is going to come. So, covering is like we cover all topic of sets in one night by going through this multiple choice. So it means that you should be able to answer all of the questions, right? What other topics we covered? We covered what?
Percentages.
I mean, topics that if you get the questions, no matter what come, we can do it. Percentages to some degree. What else? What other questions cover, guys? Cover sets. Difference of two squares, right? The fraction, the power, percentages. This is a set notation, 2 to the m power. So basically that is. What guys, what if they gave you something like this? 88 times 5 minus 88 times 4. 46, for instance. You know you can actually factorize this, right? Factor out 88, right? And so what would you have? 88 here? What would you have in the bracket? 5 minus 46, yeah. Alright, let's put a bigger number here. Let's put 65 here and make it make more sense. And that would be the answer, isn't it? And then we can say 88 times the difference of this, isn't it? So that would be what? 15 plus 4, 19. That would be the answer, isn't it? There's actually a question like this on this paper. Is on this paper I saw that question? Maybe not this question, not this paper here. No, not this paper. It's actually, I think it's 2021, July 2021. Can I see something here? Let's look at this one. This is July 2021. 1 second. One second, guys. Oh gosh, I wrote this one already. This is July 2021. Have you seen this paper yet? Basically asking the same questions again, some of the questions again. No, I didn't see that. That's weird. Okay, it's one of these papers, but it's not this one either. I saw that one. That's weird. I swear I saw the paper recently. Anyways, you guys realize they asked this question again, right? A similar question here. What's the answer for this one? Oh, they put the dash underneath this time. What the answer would be for this one? D? Yeah. Everybody agree with that? I can see you went through this question already, man. Y'all see the answer for this one? For this one, question 7. This one here. Came in what? 23 as well? Okay. Came in 21 as well. It's 21 paper I have here. So this is what? What's the answer for this one? D. Where is that? Equal 92 and 4, right? So, and that's the only option that includes 92 and 4. Easy stuff, right? What about this one? This one is, again, this one comes as well. Let's see if you could answer this question here. What is question? What answer this one will be? this one?
I don't see it.
What's the answer to that one?
2 to the end.
To the third, right?
Yes.
So remember we learned that earlier, right?
Yeah.
And y'all learn this one as well. So take on this one quickly. Set of positive integers. Which one? A finite set. Finite means what? You can count it. You have a fix. You stop. You can stop. You can count and stop. Infinite means what? Go on forever. Improper set means what? It's a subset of itself. Remember I mentioned that? When I said it's a subset of itself, we call it what? A what kind of set? Improper subset. So, on the empty set, we know the empty set is, isn't it? The numbers inside. So, instead of positive integers, you'll learn about integers tonight, isn't it? What are the positive integers? Give me the positive integers. 1, 2, 3, 4. Right. 1, 2, 3, 4. 0 isn't the positive, not negative. But it's an integer. A negative 1, 2, 3, negative 1, negative 2, negative 3, those are the negative integers. So the positive integers will start from 1. Positive integer, there's another name for positive integers. We call them natural counting numbers. Alright? Natural counting numbers. I've used this letter N, capital N, to represent natural numbers. And natural counting numbers. Those are positive integers. So what's the answer? Is it finite or infinite? Infinite. Why is not finite? Finite means what? You can count it. Can you count from 1 going on forever? You know you'll die and the numbers still carry on. You'll never stop counting. So it's infinite. In other words, if I ask yourself, what is the last positive integer? What is the last positive integer?
What's the push about the Obama?
Huh?
I just said it was.
What?
What's the Obama?
Why is the problem is we can't give you the last. What is the first number? 1? We have negative 1, that's less than 0. What's the smallest number?
It's infinite.
It doesn't. We don't know. It doesn't exist. What's the biggest number? It doesn't exist. All right. And if it exists, we don't know. It's not possible. The numbers go on for infinity. It's almost like God to me. It has no beginning, and it has what? No end. Just a journey along the number line. Alright, so what's the answer, guys? What's the C? Okay, let's see if we can actually knock off another one quickly. What about this one? This is one we didn't learn. But we can actually do this one quickly. What's the answer? That's this one. The number of universal set is equal to what? Number of elements in universal set is equal to 25, right? Number of elements in A is equal to what? 14. Number of elements in B? 15, right? What amount the intersection has? It's about 6 here. What should go here then? If in the entire set A is 14, what number should be here? Because set A only has 2 parts now, the intersection and this part over here, the A only part. So what amount should be over here, the A only part?
14 minus 6.
Yeah, 14 minus 6. What's 14 minus 6? 8. Make sense? Because 8 plus 6 is what? Right, what amount should be over here? In B only. 15 minus 6 will be what? 9, isn't it? Yeah, and check it out. 8 plus 6 plus 9 is what? 25, isn't it? 9 plus 6 is what? 15? And 15 plus? What am I saying here? Something is wrong. 9 plus 8 is what? 17? And 17... No, something is off. Oh, there will be what? Hold on, give me a second there. Something is wrong here. Number of elements in A is 14. Number of elements in B is 15, right? Intersection is 6. So 6 from 14 is 8. Yeah, that's correct, isn't it? Well, all it means is that we're going to have 2 extra number value of poles here. Alright, that means that we're going to have 2 outside. But that wouldn't make no sense. 9 plus 6 is 15, right? 15 plus 2 is what? 17? And 17 plus 8 is going to be 25. So the answer must be what? What do you ask for? A union B? Okay, so that'll be what? 8 plus 6 plus 9. What's the answer? 23. So the answer is C. It simply means that we're going to have a 2 outside. Okay, universal, it doesn't mean that it's only going to be in A union B only. You're going to have a section outside as well, right? And the section outside, we call it what? A union B complement. And in that amount, we have what? We have the number what? 2, right? If you want to count it, we'll simply say number of elements. No, let's just ignore that. Right, let's do this. 1 second. The number of elements in A union B complement would equal to what? 2. Alright, and the number of elements in A union B would be what? 23. So when you combine them, what do you get? 25. I'll give you some extra information. But there's another way to do this, right? Let me show you quickly. Another way, using a formula. Rather than drawing it, I'm wasting time. But if you want to draw it, that's fine. It'll take you 60 seconds to do that. The number of elements in A union B is equal to what? The number of elements in A plus the number of elements in B minus the number of elements in A intersect B. Alright? The number of elements in A union B is what? The number of elements in what? A plus the number of elements in B minus the elements in... Why do you think we're taking out the intersection? Why do you think we're taking out the intersection? Let's look at it. What's the number of elements in A? Let's go back up here. What's the number of elements in A, guys? 14, ain't it? And that 14 includes what? 8 plus 6, ain't it? Right. That 14 includes what? 8 plus 6. Everybody agree with that? Yeah. Added to what? That's 14. What's the number of elements in B? What's the number of elements in B, guys? 15, ain't it? And that's equal to what? 6 plus 9. That's 15. Do you realize that we're double counting? Is this 6? You realize that? When we count the number of elements in A, we counted 6, ain't it? Where is 6 in this intersection, ain't it? When we count the number of elements in B, we count the 6 again, ain't it? 6 is the intersection. Because we have it twice, what we have to do? Take it out. We have to take out one of them. So we take out the intersection. Now what's the intersection of A and B? What's the number of elements in intersection? 6. So we take out one of them. So we don't double count. Understand? So that's 29 minus 6, which is equal to what? 23. So the number of elements in the unit of A and B is equal to what? Number of elements in A, in all of A. Number of elements in what? All of B. But because the number of elements in A and B will include the intersection, and we're counting it twice, we have to take out one of them. So we subtract the intersection. Everybody get that? Yes. Okay, so let me see if you all really understand that by one question. Give me the formula for the number of elements in P union Q. Give me the formula. Number of elements in what? Talk to me, guys. Number of elements in P. Plus. Minus what? Right. Paying attention. Very nice. Proud of you. Alright. So everybody get that though? Is there any more sets question we miss? Boy, I say boy miss and then go at it boy. When we want to go home. Okay, we finished all the sets question apparently. Oh, what about this one? Look at this one, guys. It's right here. What does shaded region represent? That should be easy. The last sets question. Oh, there's one below that. Oh, we did that one already. One below. No, before you give the answer, just think about it a little bit. This is the shaded region. Not the shaded region. What's shaded? All except what? So how do you write that in notation? P complement. Right? You were saying intersection, right? Make sense now? You were saying the complement. You were saying intersection, right?
No, I said P intersection complement.
Oh, so that wouldn't work. The intersection is not in it. What shaded is just everything except P. So you put P complement. What shaded is what? Not P, but it's what? Complement. Clear? Alright, so we did 2 papers then. What about this one? Y'all get this one already, ain't it, guys? What's the answer for this one? They change up the options though. Which one is the right one? What did they change up the question? Double checking now. Same 30 students. 16 students have dogs. 16. Oh, they changed up the question, you know. You realize that? You realize that they changed it up? How many students have dogs? How many students have dogs, guys? No. They put words there instead of the number 12. 16 students have dogs. Do you realize they didn't put 12 in words? They put it in numbers. They're inconsistent with that. They put 16 in word, and put 12 as a number. Because they want you to believe that it's the old same question. Because the 12 there is the same 12 from before. But the 16 they put it in words, they don't realize it. And the remainder have neither, right? And you hear what I said? The remainder what? Have neither. So 16 own what? Dogs, right? 16 have dogs and 12 have cats. And the remainder have neither. Did this? Oh, it says, class have either a dog, a cat, or none. So what's the answer in this, guys? What's the answer? What's the answer? Is the answer A? Let's look at A. D. Okay. Is the answer? Can the answer be A?
No.
Why not?
It's not intersecting.
And it's a 12. But my answer to that would be 12 students have cats. We were told how many students have cats? 12. How many students have cats in A? How many students are within the circle of A? Altogether. 14. 14 students are within the circle of A. Everybody get that? Let's look at B. How many students own dogs? How many students are within the circle of D? 16 plus 12. You don't find this 12 within the circle of D still? It's a subset. C is a subset of D, right? So that means this 12 is a part of D. So how many students we have within the circle of D? 28. And that's not true, isn't it? So this was the answer for the last one, but it's wrong for this one. Although they changed up the numbering. What about C? C is wrong too, right? How many students? It be 18 own dogs, right? And that's wrong, so it's 16. So the answer must be what? D in this case. Y'all realize that? Why is D the answer in this case? Because they did not tell us. They didn't say those who own cats own dogs or those who own dogs own cats. So you see what I mean by knowing the options? That they can do what? Change up the options on you? Y'all seen that? Right. So you have to really understand the concepts. Else they will change it on you. And you say, boy, I think I got the answer right, but look, you see, a different question. Oh, I saw the question already. I did that question with Mr. Lennon last night. Boy, Mr. Lennon, the exam is the same question he did with us. Not knowing that they change up the options and change up the information. Yeah. Oh, yes, good point. Neither and either. And change 16 and put 16 as a word and 12 as a regular number. So you don't realize they actually change up the option. They really want to catch you out, boy. Anyways.